Previously, we have talked about kind of a little introduction to MATLAB, variables, arrays, matrices. Last time we talked about plotting. Are there any questions? Things you've been thinking about, wondering about? Maybe not, but I thought I'd give you a chance. Okay. That sounded like a question, but not for me. Okay, so let's get started today. Today we will talk about some conditionals, things like greater than, less than, equal to, if statements, for loops, and while loops. So last time when we were in lecture, we did an approximation of e to the negative x, the exponential function. Today we're going to do something similar to that, but a bit different. So let me start a new script. Okay. So in MATLAB, there are things that sometimes you need MATLAB to make a decision for you based on some input. Okay, so we can say, remember, it's always good to start with clear, close all CLC. I'll go ahead and save this as script 4. And today we're gonna first focus on conditionals. So let's say we have some value x equals 5. We want to check what the value of x is and display something maybe to the command window over here when we press run. So we could say something like, well, before we do that, we could say x equals 5, y equals 6, and we could just check. So let me just take this over here into the command window. We have x and y. We can just ask questions of MATLAB. Is x greater than y? Okay, it gives us a logical, this is a data type. Okay, so the type of data for x and y is like, it's a number, floating point. What this gives us is a logical, which means it's either a 1 or a 0. A 1 means true, a 0 means false. So we could even store that value. We could call it log 1, x greater than y. So this is asking a question of MATLAB. Is x greater than y? Log 1, the value is 0. It's a logical, which means no. X is not greater than y. Okay, x is less than y. So we could ask, is x less than or equal to y? Yes, it is. Is x less than y? Yes, it is. Is x equal to y? Now, notice here, I put 2 question mark or 2 equal signs, because when we put 1 equal sign, that means we're assigning the value. So what would happen if I wrote x equals y? What would happen?
The value of x or y will change.
Yeah, so the value of x would become the value of y. So y is 6 right now, x is 5. If I say x equals y, we're going to take the value of y and put it into x. So now x equals 6. Let's change x back to 5. So how we ask the question in MATLAB is with 2 equal signs. Does x equal y? And it doesn't. Okay. Good, so that's pretty simple. It's what you would expect with one exception, and that is the 2 equal signs. So we can use these things in MATLAB to help us make decisions. So, for example, if we want to, we could make a little game. Maybe, I don't know if you've played this game called 20 Questions. So in the game 20 Questions, I play this with my children sometimes. I think of something, only I know it, and my children can ask me questions. So they might ask a question like, is it an animal? They have to ask a yes or no question. I say yes or no. Yes, it is an animal. Okay, is it smaller than me? Yes, it is. Okay, is it black? No. Is it brown? No. Okay, questions like this, just yes or no. And you get 20 questions, and then you try to guess what the thing is within 20 questions. So we could imagine creating a similar game like this in MATLAB. So what we could do is we could save maybe a secret number. We'll say 5. Let's say just the number has to be on the scale from 0 to 100. It has to be between 0 and 100. So maybe we'll change it. We'll say 25. And then we're going to ask for a user input. Okay, so what we're going to do here is say guess. So this will be the user's guess, the person playing the game. They're going to guess. Let's see how to do this. Well, actually, what we're going to do is this first. We're going to display to the screen we're going to display press 1 for less than, press 2 for, let me put this on a different line. Press 2 for less than, no, excuse me, greater than. And press 3 for equals. Okay, so this is going to decide, is the person going to ask, is it less than, so we're going to play a type of 20 questions game, okay, where the computer knows the score, you don't know it. So we're going to ask, is it less than 50? Is it greater than 10? Is it less than 40? Okay, whatever, questions like this. So let's just run this to show you how it displays. Okay, when you do display, D-I-S-P, okay, whatever's in between your parentheses with quotations, single quotations, that will display to the screen. Okay, so this displays to the screen, and then we're going to take the user input. So this is a conditional. We'll save it into a variable called conditional. The user input. Okay, so I'm just going to press run so that you see what's happening. So this input here, what I wrote on line 11, means I'm asking the user in the command window for some input. Okay, I'm asking the user specifically to press 1, 2, or 3. So let's say I press 2, then I press enter. Okay, we came to the end of the code over here, so we're done. But notice here, the value 2 is now in the variable cond, conditional. Okay, that's what this line of code just did. Okay, so this is an interesting function to remember, this input function. It takes user input from the command window so that you can have some control. Okay. So now what we're going to do is we're going to say, let me open up PowerPoint just to kind of make a flow chart. It's always a good practice of what we're going to do. So here in this flow chart, we're going to say, we're going to ask a conditional. Perfect, flow chart. Okay, here we're going to ask if conditional equals 1, then we're going to check something else. Conditional equals 1. Then we're going to remember what conditional was. So the value 1 was less than. So that's what the user is asking. Conditional equals 1. Then we're going to ask, is x less, or excuse me, is the guess less than, no, sorry, is x less than the guess? So we need need to go ahead and get another input for the guess. Here we're going to input value. We're going to press run. Okay, so I'm going to press 1 and enter. And now I'm going to check. I want to ask, is it less than 50? So I'm going to type in 50 and press enter. Okay, so now our value conditional is 1. Our value guess is 50. Now, let's go back to our flow chart. We have conditional and we have guess. Let me go ahead and just bring this over here. Just for reference. Okay, so here this means yes. So if conditional equals 1, that's yes. I'll go ahead and change this to conditional equals 1. That's a question. If it's yes, then we're going to ask, is x less than guess? Okay, then we're going to say, we're going to have a condition for no. What should we do if the answer is no? We can ask another question. Is condition equal to 2? Okay, so that means we're asking, is it greater than? If it is, we're going to ask then, is x greater than guess? If the answer is no, then we know that condition must be 3. And we're going to ask, is x equal to guess? Okay, so this is a flow chart. It's going to tell us where to go. So we need to convert this into code. You need to convert this into code. So let's go back over here. And we're going to ask if, this is how we ask, this is a conditional, an if statement. If, what are we asking again? if condition equals 1, okay, so if CO and D equals 1, okay, remember we're using our logical expressions here because we're not assigning a value, we're questioning. This is what we'll do if it's true, if condition equals 1. Else, if, so a different condition, if condition equals 2, so this, if we'll do what's in here, if it's true that condition equals 2, otherwise, else, here it's true that condition does not equal 1 and condition does not equal 2. So we can safely assume, unless the person made an error, that condition equals 3. Okay. So let me just do something in here. Here I'm going to display condition equals 2. Here I'm going to display, excuse me, condition equals 1. Here I'm going to display condition equals 2. And here I'm going to display condition equals 3. So let's press run. I'm going to press 3 and 25. Okay, notice it displayed this to the screen. How did it get that? Well, it checked. Does condition equal 1? It asks this question, does condition equal 1? The answer is no. So it goes on to the next one. Does condition equal 2? Nope. So it goes to the next one. Since it says else, this is anything else. If condition is anything else, then do what's inside of this. Okay, so that's what it did. It displayed cond equals 3. That's why we have that here. Okay, so let's press run again. And we'll press 1, input value 40. Okay, it displayed cond. Okay, how did it display cond equals 1? Well, it got to if cond equals 1, well, it does. So let's do what's in here. Let's do what's in here. So it's going to display cond equals 1. Okay, any questions about this? It kind of combines some concepts. I want you to type in the chat how clear this is from 0 to 10, where 10 is very clear and you totally understand it. Okay. Type in the chat one thing that's unclear. If it's unclear, just type what line of the code is unclear to you. What line of the code is unclear? Is it the same as C++? I don't know. I don't know C++. Sorry. Why should you put input? You don't have to. You don't have to. So this is just where I'm like building a game, sort of. So it doesn't have to involve any input. You could just say something like this. Here, I'll make a new line here. Let's just make one called QW equals 5. And we're going to say if QW equals 6, y equals 2, else y equals 3, and end. Okay, there's no input here. What will be displayed when I press enter? What will be displayed? Actually, nothing will be displayed. What will be the value of y? What will be the value of y when I press enter? That's right. Y is 3. Okay, so it doesn't require input. We're just using input to make it a little more interesting and fun. Okay. So this does not really get to our game though, right? So we've done what this says, we've done it, but now we need to ask in the case that it is 1, we need to ask, is x less than guess? Okay, and actually this should be a conditional also, not a rectangle. So is x less than guess? So similar to the others, this will have, in the case that it's yes or no, different options. So what are we going to do? If it's condition 1, that means we're asking, is it less than? So we could go ahead and display. No, we don't need to display. We'll just say if, so this is like an embedded if statement. If x, this is our secret value that only the computer knows, is less than guess, display x is less than guess. Just type this, x is less than your guess. Oops, so let's say else. So if it's not, that means x is not less than guess, which means it could be equal to or greater than guess. We're going to display x is not less than your guess. Okay, now let's just kind of copy this, but we're going to change it because condition 2 is greater than. And then here we'll paste it again. And we're going to ask equal to. And then display. This is just what's going onto the screen. So we don't need to type 2. Okay. So let's press run here. And let's just say we don't know. We don't know the secret value. So we'll say 1. We're going to ask, is it less than 50? Okay, and then it tells us x is less than your guess. Okay. Let's press run again. Let's press 1. Is it less than 30? Excuse me. 1, 30. Okay, x is less than 30. Now we'll say we want to see, is it greater than 10? Yes, x is greater than 10. Okay, any questions about this? Okay, why do you put 1 first? You mean for input? Is that what you mean? You don't have to. You can do whatever, you can ask whatever question you want. So input, I could say, I want to ask, is it equal to? Okay, so is it equal to 50? No, x is not equal to 50. Press run again. I want to check, is it equal to 25? Yes. Okay, I win. Other questions? You can put in any number you want into there. Let me ask you a question. What would happen if I put in 5 right here? If I press enter, what will happen? You might have to turn on your microphone to answer this question. Maybe raise your hand if you think you know.
Could you repeat your question?
Yeah, what will happen if I put in 5 here? It's telling me press 1, 2, or 3 for these different options, but I'm going to put in 5. What will happen?
Nothing.
Nothing? Well, let's look closely. Let's look closely here. So it's going to get to this if statement first. Remember, 5 is what's going to be put into condition. So this cond variable will be 5. So it's going to ask if cond equals 1. It doesn't. So we're going to go here. Else if cond equals 2, it doesn't. Okay, so we're going to go down here. Else if, okay, else, that means for any other value of cond, do this. For any other value of cond, do this. So it's going to think, it's going to ask this question. So I'm going to say 24. Okay, so it went here. 24 was my guess. So it said, is x equal to 24? It's not, so it goes here. Display x is not your guess. And that's why we got this. Okay, so that's kind of a mistake in our code, right? Because 5 actually doesn't have a value. We needed the person to press 1, 2, or 3. What could we change about this to make sure that it only works for 1, 2, or 3? Use your microphone.
The input value goes equal input.
So you're saying change what again?
Goes equal input.
Right here?
No, the down. The next line.
Right here?
No.
What line?
13.
Line 13. Okay, so what would you change this to? So yeah, there are different ways we can do it. What I would recommend is saying adding another else if, and say else if condition equals 3, and then adding an else. So this else means in all other cases. Okay, in all other cases. So anytime you see an else, that's what it means. So here we could say, we could use this function called error. Okay, we could just use this function called error. What happens when we use this is it's going to give us an error message. Okay, a custom error message. Oops, 1, 2, or 3. So let's press run. Let's say I put in 5 and then 25. Ooh, okay, we get an error. Input value 1, 2, or 3 only. Okay. So these are our conditionals or if statements. If statements are very powerful for making decisions in a code. Okay, the general structure is you must have the if and you must have the end. You have to have the end. You can optionally have the else. So you could say just if and else. So this is in all other cases, do that thing. You could also have these else ifs, okay? So those are kind of a second option. So you have if, and then else if, which is very specific, and else if, another very specific thing, and then an else, which is in all other cases, and then the end. So MATLAB will go through, remember MATLAB always goes in order, but it will only run the code inside of the case that's true. Once it runs the code inside of the case that's true, so let's say condition is equal to 1, it runs this code, it's going to skip all the others and go straight to end, and then to the next line. And it will continue going in order. Okay. Great. Let's move on to talk about for loops. For loops. Remember, I called this game 20 questions. I called this game 20 questions. So let's say that we want to repeat this 20 times. Okay, we're going to give the user 20 chances to ask a question. So we're going to add a for loop. We're going to say for C, the counter equals 1 to 20. Okay, for C equals 1 to 20. So that means we're going to do this 20 times. I'm going to, okay, so everything in here is going to happen 20 times. We can know, we could, actually, before we do this, let me just start a new one to introduce for loop. A for loop, the syntax is like this. You say for, you have a variable equals, you want to basically work through an array. So you could say x equals 1 to 50 or 1 to 5. And you can just display x. You can do something like this. So if we press run here, save it as script 5. Okay. It did everything in here 5 times. Okay, so the value of this x, the first time through this loop will be 1. The next time through the loop will be 2. The next time 3 and 4 and 5. Okay, this is the same syntax that we used for arrays, if you remember. Okay. We could also say x equals 1 step by 2 all the way to 10. 1, 3, 5, 7, 9. Okay. We could say for x equals 1 step size 1 all the way to 6. What will display here when I press run? when I press run, what will display? That's right. 1, 2, 3, 4, 5, 6.
1.
There it is. Let me give you another example. Let's say we have a an array called y, which has the values 2, 4, 6, and 8. Okay, remember here, if there are only 2 values, it assumes a step size of 1. So it's going to be 1, 2, 3. I want to do this. Display. Actually, I want to do this. X plus y of x. When I press run, what will display? I'm going to give you about 30 seconds to think about this. I'm going to give you 30 seconds. When I press run, what will display? Okay, if you have an idea of what you think might display, you could type it out. Okay, I see one guess. It's a good guess. Does anyone agree or disagree? I'll give you 10 more seconds. Okay. So let's go through this one step at a time through the loop. So the first time through the loop, the value of x will be 1. Okay, so when we come here to do this calculation, this value will be 1. And then here we're going to say the first value of y. Okay, y is a variable here. The first value in it is 2. So we're going to say 1 plus 2, which should give us a 3. So it's going to be 1 plus 2. The second time through, okay, so we get to end, but we go back up because it's a for loop. The value of x now is going to be 2. So we're going to say 2 plus y of 2. Well, y of 2 is 4. Okay, so the value is going to be 6. The value here was 3. Okay, we get to end, but we go back up because it's a for loop. Now the value of x will be 3, which is the last value. So this is our last time through the loop. So it will be 3 plus y of 3. Well, the third element of y is 6. So it will be 3 plus 6, and we should get the value 9. So the values that display to the screen should be 3, 6, and 9. Let's press run. And there it is, 3, 6, and 9. Okay. Let me add one complication to this. Okay. Now I'm going to give you 30 seconds. I want you to go through the same process I just went through, step by step, line by line. Give me the 3 outputs from this for loop. Give me the 3 outputs from this for loop. Okay, I'm seeing a few answers here. I'll give you about 10 more seconds. Okay, so I see a lot of different answers. So let's go through this line by line. Okay, so we have the value of y. We get here to the for loop. X, the first time through, will be 1. Now we come here. If x equals 1, then z equals 4. Okay, let me just keep track over here, right here, of what the values of x and y are. So the first time through, x equals 1. Okay, we come to here. Since x equals 1, this is true, we enter here. So we assign the value 4 to z. Okay, we have to skip this. We go straight to end. Now we say x, which is 1, plus y of 4. So that's 1 plus 8, which is 9. Okay, we display 9 then. We come back up to the top. For x, okay, so now x becomes 2. Let's go ahead and change this. If x equals 1, okay, it doesn't. So we go else, so then z equals 2. We go to end, then x. Okay, so here now we have 2 plus y of 2. So that will be 2 plus 4. So that will give us 6. So just to keep track, we had a 9 and then 6. Now we go up again. X is now 3. If x equals 1, okay, it doesn't. So we go else, z equals 2. Okay, end, good. X then is 3 plus y of 2. So that's 3 plus 4 equals 7. And that's the end of the for loop. So let's press run just to show it. 9, 6, 7. I want you to type a value in the chat from 0 to 10 that shows how much you understand this. 10 is perfect understanding. Okay, good. Okay, so this is a for loop. A while loop is a bit different from this. So a while loop doesn't just go for a set number of times like this. A while loop goes while some condition is true. So we could say this, while, actually, I'll just save this and start a new one. Okay, so here I'm going to use a Taylor series. Taylor series is an approximation of another function in a series. So the Taylor series approximation for e raised to the x, so that's exp of x, is this 1 plus x squared times 2 factorial plus x cubed times 3 factorial, and so on. Okay, I think you see the pattern here. We could actually change this to say x raised to the 1 times 1 factorial. All those ones just simplify out. And this could actually be x raised to the 0, which is 1, times 0 factorial, which is also surprisingly 1. Okay, so you see the pattern. This value here just changes from 0 to 1 to 2 to 3, and you just add them over and over and over. Okay, so what we're going to do is we are going to see how many times it takes, how many times through a for loop it takes to get within a certain percentage of the real value for e to the x. So the true value of e to the x, we can calculate in MATLAB like this, exp to the of x. Okay, so let's just choose a value for x. We'll say x equals 3. We'll say x equals pi. MATLAB has pi stored. We'll say x equals pi. The true value, exp to the x. Now what we're going to do is say while, we're going to say while the error, we'll call it ERR, is greater than or equal to 0.0001, we're gonna do what's inside of this loop. Otherwise, we're going to end. Okay, so error, we need a value for, okay, because we're checking it to even enter this for loop. So we're just gonna initialize the value here. Error, we'll call 1. Okay, so now we're going to say our approximation is equal to our previous approximation plus x raised to the, we'll call it c for now. We'll call this value c times c factorial. Now, to do a factorial in MATLAB, you do this factorial of the value. So factorial of the value means 3 factorial. So if you don't remember, factorial is just 3 times 2 times 1. Factorial of 6 is 6 times 5 times 4 times 3 times 2 times 1. Okay, that's the factorial. MATLAB will do that for you with this function, factorial of C. Okay, well, what is C? Well, the first time through, we want C to be 0. The next time through, we want C to be 1. The next time through, we want C to be 2. So each time we go through the loop, we want C to increase. So if we want it to be 0 the first time through, then we need to start it at -1 and add 1 as soon as we get into the loop. And then we're going to add, okay, approximation equals the previous approximation. So we need to initialize this one also. Let's initialize it at 0. Okay, so this would be 0 plus x raised to the 0 times 0 factorial. So we just added this to 0. And that's our approximation. Then we need to check, is it close? So our error value will be the true value minus approximation. We can take the absolute value of it. Okay. When we get to end, we're going to go back up to while and check. Is error greater than or equal to this value? Okay, if it is, if that's true, then we're going to do this again. If it's false, we'll skip to end. And then here we'll display approximation. And then we'll display also true value. And then we'll display the number of times through loop. That will be the value C. Let's press run here. It's a good note. We cannot name the file the same as a variable. Okay, so we'll just call this script 6. Press run. Okay, it's running, it's running, it's running. Will it stop? Is it converging? If not, means we maybe did something wrong. Okay, I stopped it. Let's just see what the approximation is. Ooh, infinity. It's not converging. Let's check what the true value is. Okay, that's the true value. Look how many times we had gone through the loop. Okay, so something has gone wrong. Error, of course, is infinity. Okay, so what we need to do is, let's just go one time. So let's change this to while C is less than 2, less than 1. Let's press run. Okay, so our first approximation was 4.1416. Is that right? So it should be 0 plus x, which is pi raised to 1 times 1. So that doesn't seem quite right, does it? copy this over. Okay, so it did it right this time. Let's go through line by line. X equals pi. Okay, the true value here. And then we'll input these initializations. Okay, C equals C plus 1. So C is 0. Our approximation excuse me. Sorry. I know what went wrong. This Taylor series is wrong. This is divided by. So we just need to change this here. Let's press run now. We're going to change this back to error less than error less than 0.001. Excuse me, is error greater than 0.00. Okay, now here we go. It's working. So notice here it went through the loop 12 times. Our approximation was 23.1401. The true value was 23.1407. So it stopped there because the error was no longer greater than 0.001. It was less than that. So what we could do here is store the approximation. So store of C plus 1 is equal to approximation. Let's press run here and plot store. Okay. So what this is showing us is our approximation. So each iteration, the first time through, it was 3.14. It slowly increased and it's converging to the true value, If we stored our error, we would see something similar. We could plot store error. What do you think this will look like? Someone describe with your words. What will this look like? Look the same? Is our error increasing or decreasing? Yeah, our error is decreasing. Okay, so let's plot store error. That's what it looks like. So with time, it gets closer and closer and closer to 0, and it finally stops when our error is less than 0.01. Okay, so it finally got less than 0.01 over here, and we stopped. Okay, so this this may look quite similar or quite familiar to many of you who've taken numerical methods. And this is the kind of thing you do in that class. Are any of you in numerical methods now? If you are, type 1 into the chat. If you've taken numerical methods already, type 2 into the chat. If you haven't taken it yet, type 3. Or yeah, 3 is fine. Okay, good. So most of you are either in it or have taken it, with one exception, haven't taken it. So for those who have taken it or are in it, I want you to type A if this looks familiar, and B if this does not look familiar. Okay, good. Okay, so it is 5:07. We have covered if loop or if statements, conditionals, for loops, and while loops. What I want you to do is, with the time left in class, I'm going to send a file, this first one that we worked on, which was just full of conditionals. And I want you to take it and add a while loop, so that this will run until you guess the right value. Okay, I want you to take this code. So this is script 4. I'll send it to you. And make sure this is saved. Okay, script 4, I'll send it to you. I want you to download it and make it run automatically until I guess the exact value. And then it will stop. Okay, so I'm going to give you until 5:20 to work on this. And at 5:20, I will unmute and I will do it for you so you can see. Okay, are there any questions before you get started?
No.
Okay, all right, so go ahead and do that, and I will talk to you again at 5:20.
Doctor, are you going to send the code?
Sorry, for some reason, my chat defaults to messaging individual people. So here I have sent it now. I think you can see it now. All right, everyone. Was anyone able to successfully convert this file into a while loop that runs until the guess is right? Press into the chat 1 if you tried and failed, 2 if you tried and succeeded, and 3 if you didn't try at all. All right. Well, I'm glad you tried. Failing isn't failing in the way that we often think of it, but failing here is not a bad thing, right? That's part of the learning process. So let's go through and see what we can do. So we're gonna add a while loop, and remember it has to have an end. So while and end, and I'm gonna indent everything in between here. Okay, this is a good practice to just do that. So we're gonna say while correct is not equal to 1. Okay, so this is a condition we didn't cover before. You don't have to do it like this. Okay, you could say while correct is equal to 0, but I just wanted to introduce this to you also. While correct is not equal to 1. So that means if correct, I'm gonna say correct is 0 right here. And all I need to do is leave correct at 0 until which case? This case. In this case, correct equals 1, right? So this means we got it right. So I'm gonna say you're right. X is equal to your guess. Okay, so let's just press run here, see what happens. So first I'm gonna guess, is it less than 50? Okay, X is less than 50. Actually, I'm gonna change this a little bit. So instead of using these values, I'm gonna actually use the letter, okay? I'm gonna do this kind of fast, so I'll let you come back and look at it. But the general principle here is, since you're using a character, you have to put it in quotes like this. And I think we can do this. Nah, we can't actually. Yeah, okay, so let's not do this. Let's just say 1, 2, 3. Okay, let's just press run and see. Okay, so I want to know, is it less than 50? Yes, it's less than 50. So now I'm going to ask, is it greater than 20? Yes, X is greater than 20. Okay, so then I'm going to see, is it less than, so less than is 1. Is it less than 25? No, X is not less than 25. Okay, so then I'll see, is X less than 30? Yes, so we know x is less than 30, but it's not less than 25. So we could just start guessing values. Is x equal to 25? Yes, it is. Okay, and then it stops because we changed the value of correct to 1. We change the value of correct, went up back up to this while loop. Is correct not equal to 1? No, because correct is equal to 1. So we go to end, and that's the end of the loop. Okay. Now, remember we called this game 20 questions. We called it 20 questions. So we could say, let's do this until you reach 20 questions. If you reach 20 questions, then you're done. You can't play anymore. Okay, so in this case, we could say while correct is not equal to 1 and C is less than or equal to 20. Okay, we'll say C is equal to 0 here, and then as soon as we enter, C is equal to C plus 1. Now, so this will run until both of these things, or while both of these things are true. Okay, only if both of these things are true. Okay, so this is a logical statement. If correct is not equal to 1 and C is less than or equal to 20, then you can do what's inside of it. If one of these is not true, then it will end. Okay, so let's change this to 5 just to make it run faster. So this is not 20 questions, this is 5 questions. So we'll say, is it less than 100? Yes. Okay. Is it less than 50? Yes. Is it less than 30? Yes. Is it less than 20? No. Okay. Is it greater than 25? Yes. Okay. Is it equal to 28? No. Oof, we stopped. Okay, the reason we stopped is because C was not less than or equal to 5 now. So it broke out of the loop. Okay, we can type the value of C. C is 6. Okay, so we just played 5 questions. Okay, any questions about that? Okay, let me send you. Do you always assign 0 to C? No, well, it depends on what you're doing. So I like to do that and then just add 1 to C. This C, I generally call it's called a counter. Okay. So if you do it right before you enter and then add as soon as you go in, then it's a good practice to start at 0. And then as soon as you get in, it's at 1. If you started at 4, for example, then C would be 5. You'd only get to do it once. Actually, I guess you'd do it twice because of how the while loop is working. So we would, if we wanted it to be true only, so we did 6 questions there, not 5, because it was less than or equal to. So we need it to be only less than. Does that make sense? Generally good practice to start at 0 and then just add 1 each time. This is different from C++. In C++, that's what it's named on. You would say C++, and that's your counter in C++. It adds 1 to the value of C each time. That's how it has its name. Okay, other questions? Let me send you this file and other ones. So we did script 4 and 5. I'll just send 4 right now. And then 5. And script 6. Okay, great. Well, it seems like there are no other questions. Thank you, and I will see you around. Bye-bye.
Dr. Bruce.
Yes, okay, let me stop the recording. I see your question. 1 second.